So I'm very excited to share this paper, which is titled An Outcome Test of Discrimination for Ranked Lists. And this is joint work with my great co-authors, Guillaume and Yinyin. So to set up this paper, there's a large literature in many disciplines, including economics and computer science, focused on detecting whether a decision maker, either a human or an algorithm, is biased against particular groups, say women or minorities. And the canonical setting studied in this literature involves evaluating a binary decision on the part of the decision maker, say, should we grant a defendant pretrial release? Should we give a potential borrower a loan, or should we admit a student to college? But in many practical settings of interest, the decision maker produces not a binary decision, but a ranked list of candidates. So this is going to be particularly relevant for online platforms where, say, Google produces, a search list of websites. LinkedIn produces search results of candidates meeting various criteria. And a variety of social media platforms produce ordered lists of posts in a feed. And in addition to being relevant online, ranked lists are also relevant in certain settings with human decision makers. So for example, hospitals rank potential residents for the National Residency Match Program, or in a variety of lab experiments in psychology and experimental economics. People ask participants for preferences over, say, which of the other participants would they be interested in working with. And so in this paper, we're going to think about how can we test for bias in the context of settings where the decision maker, be it a human or an algorithm, is going to produce a ranked list. So to give you an overview of what we do in this paper, we develop tests of bias in ranked lists in the spirit of the definition of bias first proposed by Gary Becker in the 1950s and used throughout the economics literature on discrimination. So in particular, we're going to ask, does the ranker sort candidates based on the expected value of their work? And what we'll show is that a sharp testable implication of unbiased behavior, according to this definition of unbiasedness, is a set of moment inequality restrictions. And intuitively, these moment inequality restrictions say you shouldn't be able to flip the position of adjacent candidates whenever you see a particular orientation of groups in the list, say men first and women second, and by doing this flip, systematically improve the objective on average. And we'll then illustrate how these inequalities can be tested statistically, and we'll show that the tests seem to work well in a validation exercise using data from